Okay, so it's already a fucking minute into this, so... Hello! So this is going to be our quick demonstration on how to build the ultrasonic sensor and connect it to your Arduino so then you can utilize the code that will be shown later on in this video. So, all that you're really going to need is 4 wires, preferably a red and a black, or power and ground, and then 2 colors to represent your trig and echo pin. You're going to need a HCSR04 ultrasonic sensor, and make sure that it has all 4 pins connected to it still. And you're going to need your Arduino board along with the data cable that comes along with it. So, okay, so we have our 4 wires, sensor, Arduino, and the data cable along with our breadboard, which was not previously mentioned. This will be our building blocks, our main foundation in order to build everything else. So you're going to take your HCSR04 and just place it wherever is most convenient for your board. I'm just going to set it along the left side. And what you're going to do is don't connect your Arduino up to your computer just yet, because you should not be wiring whilst you have power going through. So, before we start fully building, on the chip, so as you can see on there, it says VCC, trig, echo, and ground. You're going to need to keep track of this, so from the left to the right, and make sure that you have all of this in mind, because for the code that I am using specifically, trig goes into pin 9, and echo goes into pin 10. And if you're using the same code as me, then that's what you will be following too. Unless you've changed your pin output, your inputs and outputs to different pins, then follow that as necessary. So, ground for me is on the right, and voltage is on the leftmost pin. So, leaving trig and echo as the 2 in between the two. So I'm gonna connect them into my power and ground in my Arduino, which that's my 5-volt pin there, and that's my ground right here. Nice. Now, I'm going to use blue for my trig, and we're going to set it right in there, and we're going to put it into pin number 9. There we go. And then we're going to take my orange and put it in for my echo, which is right beside the ground, and put it into pin 10. There you go. And now you can take your data cable and connect it up to your power source, and you will most likely see it glow up. There you go. And now you can run the code. Hello! This is just a little overview of the code. So this is for using the ultrasonic sensor, and it's just a quick run over and demonstration of what it is and how it works. So you set 2 constant ints for your trig and echo pin on number 9 and 10. It can be on any other pins, just as long as you remember which one is which. I define my variables as duration as a long and distance as an int, and set my void setup to set my trig pin as an output, echo pin as an input. It's very important that you don't reverse these, or else it's not going to work at all, and you're not going to get any inputs. And then uh, activate serial monitor in order to actually see the measurements of the distance. So you start off by setting trig pin to low for 2 microseconds in order to make sure that it's not sending out anything unwanted, and that's so then you can just make sure that you're reading what you want and not extra stuff. So then you set it. So then after you have it set to low, set it to high for 10 microseconds, and then put it back to low so you can send out your ultrasonic waves. Sorry, my voice is a little bit stuffy this morning. Then duration, which will end up being used to calculate your distance down here, uh, is what then in which will be you make it equal the how much how long the echo pin is reading input. So all the reflected waves will be read in by the echo pin, and it will be utilized to as a integer that we can use to multiply to get our distance. And then you print it to the serial monitor, and at, that's at the very basics how it works. So serial monitor, you can see it's getting real fast. So if I just set my block here in front of it, 6 centimeters away, a little bit closer to 7. There we go. So, and I do have a ruler here just to measure it out. So it's 6, and I can bring it like about to 14. Yeah. And bring it in and back from there. It, of course, basically goes pretty far if we measure it out. I think it has, if I recall correctly, it's about a 4-meter maximum calculation distance. But also, as you can see, the actual numbers are jumping from anywhere from like 77 to 120 or 123 I've seen. That's just because the surfaces back here are very uneven. But if I were to get something that has a bit of a better surface to grab onto, it starts to become a lot more consistent. Although still, because it's a little wavy, it can get its spikes and dips. But then if I take something that's actually solid and just bring it back, and as long as I level it out with the sensor, it reads a lot more consistently, of course, with a little bit of inaccuracy because of my handshake. So it can go. So it's rating at about 70, almost 80. And I can just bring it right back up to 5 centimeters. And that's that. So, yeah, that's how you virtually use the code. And you don't just have to use it for calculating distances, it can just be for detecting solid objects in the way of a robot or anything else that you can really think of. Just this is a small demonstration of how to give you some ideas of how to use it. Hello! This is just going to be a small talk about the actual function and how the ultrasonic sensor works. The ultrasonic sensor uses something called piezoelectric ceramics. They expand and contract depending on how you pass electricity through them, as you can see in D and E, changing the polarity of how you place your electricity will cause it to contract or expand accordingly, or applying a sinusoidal wave where the electricity is going
positive to negative, causing it to contract and expand over and over again, which is what we use in order to make our sound waves. Now, there are two piezoelectric sensors on the actual sensor itself. One that's the sender and one that's the receiver. The sender will go through and have electricity passed over it in order to expand and contract very quickly to create those sound waves that will then reflect off of your surface. And then when it comes back, it will be sent to the receiving sensor, which will take the vibrations themselves and then pass them through as a voltage that can be read by a computer. It The way that works is complicated and simple at the same time. It's simple for understanding, but it's complicated in the way that it actually does so. And this is just a little bit of a diagram of the actual sensor itself, the cylinders that sit on the front. The piezoelectric element will sit right there and it will launch your wave. And then just on the actual sensor itself, there would be a second one of these where it will take the wave and it will be reflected into it and just have the voltage being read by a computer so then it can be converted into a measurement like I have had it. Now, you can buy these virtually anywhere. I have three little examples here. One for Spark Fun, which has them set for about $4.50 a piece. Amazon, which has $13 for a set of 5 and some jumper wires, male to female and female to female. And then in DigiKey, part number 3942, and they run for about $5.79 for one. So you can find them virtually anywhere. This one seems to be the best value, but also it's Amazon, so there might be a bit of a issue. There could be issues with it. I have not personally bought any from here, but they do seem to be anywhere that you look, you can most likely find them for a pretty good price. Like Amazon has a very cheap price, and SparkFun has it pretty cheap. Also, pick whichever one sounds the best for your version of payment or how it be. So that's my video on the HCSR04 ultrasonic sensor. Hopefully you learned something from this. Have a great day.